Hello Chem 1A, this is Chapter 1, Lecture Video 3, and we're going to be discussing physical chemical properties and changes as well as energy. So let's talk about some physical properties. Physical properties help to describe the substance, specifically the appearance or properties that are inherent within the substance without having it having to change. For instance, its color, its physical state at a certain temperature, its melting point, its boiling point, its density. These are all physical substances. So if we're looking at this picture of a huge chunk of sodium chloride, table salt, you can see it has a clear it's a clear solid. Um, it is in the solid physical state at room temperature. I don't know what the melting point of sodium chloride is. I'm sure it's pretty high. It's probably in the 1500s, I think, or maybe 2000 degrees Celsius. Boiling point would be even higher than that. The density of sodium chloride, I think, is around 3 grams per milliliter. So these are all examples of physical properties. We can separate physical properties into kind of two groups: extensive properties. These depend on the amount of substance. Something like saying this block of sodium chloride is 50 grams. Well, if I had a different amount of sodium chloride, the grams would be different. So that would be an extensive property. Its volume would be an extensive property. Um, how much volume I have depends on how much sodium chloride I have. Intensive properties do not depend on the amount. For instance, density, melting point, boiling point. These are all going to be the same value regardless of how much sodium chloride I have. All right, so that's intensive versus extensive properties. Let's talk about changes. Physical changes are a change that does not entail any change in chemical composition. In other words, what I have before the change is still what I have after the change, as far as substance-wise, right? It doesn't change the identity of the substance. For instance, solid iron melting in a blast furnace. This is just simply iron solid going to an iron liquid. It's still iron before and after the change. Physical state changed, but the substance didn't change what it was, right? Physical state changes are one of our major physical changes. Ice cube melting, going from the solid state to the liquid state. Again, that would be a physical change because we're changing physical state. Another type of physical change is a change in appearance, right? So if I took my cell phone and I smashed it with a sledgehammer, the cell phone definitely underwent a change before and after getting hit with a sledgehammer, but the substances in the cell phone, those didn't change. They just got broken up into smaller parts. So there is no change in chemical composition when we break something. So breaking something would count as a physical change most of the time. Chemical changes involve a change in chemical composition. What we started with is no longer what we have after the chemical change. In other words, if iron reacts with oxygen to form iron oxide, in other words, rust, if you've left out iron in the rain at any point, it probably rusted really good. That was a chemical reaction. There was a chemical change. We had iron at the beginning. We had oxygen at the beginning, by themselves, distinct, different things. Then after the chemical change, we had a new substance, Fe2O3, or iron 3 oxide, rust. If we take hydrogen gas and oxygen gas and we light a match, they'll react and form water. Water is not hydrogen gas. Water is not O2 gas or oxygen gas. It's its own thing. So we changed chemical composition again. The substance we started with is no longer the substance we have after the fact. So these are chemical changes. Now we can look out for chemical changes. There are a lot of identifying factors that kind of hint at the fact that a chemical change occurred. One of them is a color change, a permanent color change. Now you got to be careful with this one because if I just take a blue liquid and I mix it with a clear liquid without any chemical change, the two liquids are going to affect each other's color. we'll probably get a light blue. That's not what I'm talking about. If I take a clear liquid and a clear liquid and mix them together and it turns black, yeah, chemical reaction, chemical change. Another example is the release of energy, heat, or the absorption of energy. That can indicate a chemical change, not always. The formation of a solid or the formation of a gas. These are examples of chemical change as well, without changing temperature, I should say. So let's do some practice. Which of the following are chemical or physical changes? And we'll label them as we go. So this one hopefully is a softball one. We're boiling water here. This hopefully we all can agree is physical. This one needs to reset. This one's a little trickier. This is called a flash freeze, and what happens is the water in this container here is actually very near the freezing point of water. So it just needs a little push and then it'll immediately flash freeze. And that's what's happening. So this is also a physical change. This one, okay, so we obviously see there's a release of energy. This is definitely a chemical. Oh, wow, my writing's kind of, there we go, chemical change. Here we have another ice cube melting. So again, we're talking physical change. So just changing physical state there. This one, we need to wait for it to reset. If we're looking at this, you can kind of see a yellow gas is being formed as the test tube gets yellower and yellower. And then eventually that gas must be flammable and reach its flash point because it explodes. This is definitely a chemical change. Here we have our gloves that we would be using if we had lab on campus this semester, being exposed to concentrated fuming nitric acid. What that means is nitric acid, as concentrated as we can get it, at its boiling point effectively. And you can see that the gloves work really well. We're forming a gas there. You can see that orange gas that's coming off initially and then the heat release. So this is definitely a chemical change. Okay, this is one of my favorite demonstrations. I've always wanted to do it. Just to give you a little background, in the bucket down below him is liquid nitrogen, and in his thermos there is boiling hot water. He's dropping the boiling hot water into the liquid nitrogen, and this causes the water to go from the liquid state to the solid state. But because it's at such a high temperature when this happens, it creates tiny, 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 tiny ice crystals. This demonstration is called the cloud because if you didn't know, the clouds are made up of tiny, tiny, tiny water in the solid state, ice crystals. So this is definitely a physical change. Okay, so this one is a great one. On the tray there is mercury thiocyanate, an ionic compound, and under heat it decomposes into other things, obviously. So hopefully we can kind of see this substance is definitely not the same as it was before. This is definitely a chemical change. All right, so let's move on. Let's talk about some energy, and we're going to kind of fly through these slides. There's really only one thing that I want you to take from both of these, or two things. Energy can be classified as kinetic or potential. So kinetic energy is energy associated with motion, and that's a definition you should definitely know. So you should know that if something's moving, it's going to have kinetic energy, where things like motion at the particulate level, this is thermal energy, is a type of kinetic energy, like vibrations in those solids or the movement of gas particles. These are all kinetic energy. Macroscopic objects moving, like throwing a baseball, water falling down a waterfall. These are all examples of kinetic energy as well. Movement of electrons through a wire, right? Electricity is mostly a form of kinetic energy, or electrical energy is another type of kinetic. Acoustic motion, either transverse or compression, right? So wave motion, water moving in waves hitting the coast, that is kinetic energy. Strumming a guitar creates a compression of air around the strings of the guitar. This is acoustic motion, and it's energy, kinetic energy. All matter exists of atoms and molecules in motion. Even solids are moving, they're vibrating, right? So all matter has some small amount, at least, of kinetic energy or large amounts of kinetic energy. I don't need you to know the different types of kinetic energy here. I do need you to know that kinetic energy is associated with motion and that we can either classify energy as kinetic or potential. So let's talk about the last one in this video, and that is, okay, we talked about kinetic, let's talk about potential energy. Potential energy can be defined as the result of an object's position or stored energy. I like to use that second definition because it makes a lot more sense when we're talking about chemistry. Gravitational energy is a form of potential energy. If I hold an object really high up, it has a lot of potential energy because as soon as I let go, that potential energy will get converted into kinetic energy as it falls back to the ground. Energy stored in a spring. If I push a spring and compress it into a tiny thing, that energy there is still present. It's stored within the spring itself. As soon as the spring releases it, the potential energy will be converted into kinetic energy. Energy stored in molecules, and this is why I say stored energy works better for chemistry. Chemical energy, if we have energy stored within the molecule, that's how food works really. We eat it, our bodies decompose it, gets the energy out of the food, we use it. It's a very simplistic explanation of what's going on when we eat something, but nonetheless, that's stored energy. That would be potential energy. Energy associated with charge, partially charged particles. If you've ever been out on a windy day and you touched your car and you felt that shock from the static electricity or electrostatic energy is a form of potential energy. When we touch something that releases that charge, that's the static energy being converted into electrical energy. So that what we're feeling there, that shock, is actually the conversion of the electrostatic energy that we've built up on our body and whatever object we touched, converting into kinetic energy. Nuclear energy, fusion, fission, these are also a form of potential energy. All right, so if you guys have any questions, as always, please, please, please do not hesitate to ask me via office hours in Zoom or my email.